Simple solutions. Lesson 23. Problem 1. A concession stand offers 2 types of soft drinks, 4 different snacks. Use the fundamental counting principle to find the number of different snack combinations if a patron chooses 1 drink and 1 snack. Where there are 2 drink possibilities, 4 snack possibilities. You multiply the possibility of drinks times the possibility of snacks gives you your total snack combinations. There will be 8 different snack combinations. Problem 2. It asks you to approximate the square root of 70. When you enter this in your calculator, you will get a value of 8.366 whatever, but it asks you to approximate to the nearest tenth, so you would round that to 8 4/10. Okay. Number 3, find the measures of x, y, and z. Using geometry principles, transversal, cutting parallel lines. We see here we have a straight line, and we know a straight line totals 180 degrees. There are 2 angles making up that 180 degrees. So by properties of supplementary angles, 180 minus 140 equals 40. So x will be 40 degrees because x 40 plus 140 is 180. So x equals 40 degrees. Okay, angle of measure x. Okay, for y, angle y will equal, it also will equal 40 degrees by means of vertical angles. X and y are vertical angles. We know that vertical angles are congruent, so y is also 40 degrees. We can apply the property of vertical angles also to angle z. Z and the angle of 140 degrees are vertical angles, therefore z is congruent to 140 degrees, and z is 140 degrees. Okay, x, y, and z. Number 4. Use long division to write 1/11 as a decimal. So 11 divided into 1. We need to place a decimal there because we need additional places. 11 is not going to go into 1.0. It will go into 1.00. 9 times 99. Here comes a 1. Okay, we need more zeros. Dividing 2 digits. Okay, there's another 9. 99. Oh, I see a pattern. This is going to repeat. So we'll bring our decimal up there, and there should have been a 0 holding that place. So our answer is 900th repeating. Okay. Number 5. We're going to work this one out together. We're asked to simplify. So we have brackets and parentheses, and we will start within the brackets. So we have 6/10 plus 1/3 minus 2/3, same denominator. So I can just do the math, and that will be negative 1/3. Plus, here I have 6/10 minus the common denominator. So I'm going to place 10 as that denominator. 5 times 2 is 10, so I need to multiply 2 times my 2 up here. That's 4/10. So now I have 6/10, and I can remove the parentheses, and positive 1 times negative is also negative 1/3. So I can remove the bracket, continue on, add 6/10 minus 4/10 is 2/10, so I can remove the parentheses there. There. So now I have 6/10 minus 1/3 plus 2/3. To add these, I like to have the same denominator. 10, 3, 10. Denominator of 30. So 10 times 3 will give me 30. So I also need to multiply that 3 times the 6. So this should be 18. Minus, we're going to do the same thing here, equivalent fraction with 30 as the denominator. 3 times 10 equals 30, so I multiply that 1 times 10, 10/30. And again, denominator of 30. 10 times 3 will equal 30, so I need to multiply that 2 times 3 to give me 6. Now, our denominators are the same, so I can place that here and just do the math across using the numerators. 18 minus 10 is 8. 8 plus 6 is 14. 14/30. And of course, I can reduce that. I can simplify that to 7/15. Number 6 is this number rational or irrational? How do you know? Well, let's look at some characteristics of this number. After the decimal, there are no repeating numbers, and these dots indicates that it goes on for a while. So no repeats, and it does not stop. So this qualifies as irrational. Doesn't terminate, does not repeat. Okay, we'll move on to number 7. We're asked to solve for t. T is in the parentheses, so we can distribute the 3. 3t, multiplying times the t, plus 3 times 7, 21, equals 33. We'll subtract 21 from both sides. 21 is 0, 21 from 33 is 12. Dividing both sides by 3, need t equals 4. Okay? Number 8. The Toledo Zoo reduced the number of zebras it owned by 20 to 14. What was the percent of decrease in zebras? Minus 14 is 6. So it decreased by 6. 6 over 20. If we divide by, 3, or we divide, if we reduce by half, so 6 was 3, 20 will be 10, and that percentage, when you convert it to percents, is 30%. Okay, number 9. Was the second shape rotated or reflected? So look at the shapes in the solutions box for number 9. Was the second shape rotated or reflected? Which side of the second shape corresponds to line segment AE of the first? Okay, looking at this segment, we can see that this shape was reflected. And the line or portion of the new shape that's congruent to AE is congruent, or corresponds to, corresponds to IH. Okay. Number 10. At Millie's birthday party, the children play a game. With eyes closed, each child bobs for an apple from a container holding 10 yellow apples, 15 green apples, and 15 red apples. What is the probability that the first child will get a red apple? So first we need to establish the total number of apples. 10 yellow, 15 green, 15 red. Total of 40 apples. The probability that the first child will get a red apple, where there are 15 red, so 15 out of 40. And we can simplify that. If we divide each number by 5, we'll have 3 for the numerator, 8 for the denominator. So the probability of a red apple being drawn by the first child is 3/8. Okay, number 11. The area of a square is 169 square inches. Use square root to find the length of one of its sides. So let's see what that looks like. Let's draw a square. So the area inside is 169 square inches, which means the length of this side times the length of this side will equal 169 square inches. But when we say square, that means this value and this value, they're the same number. So which number times itself will equal 169? Well, let's take what we know. Let's start with 10. We know that 10 times 10 equals 100. 11 times 11 equals 121. 12 times 12 equals 144. 13 times 13 equals 169. We've arrived at our answer. 13 here times 13 there will give us a squared area of 169. So this side is 13 inches. Okay, 12. Find the values of A and B. Well, let me show you what the diagram is. We'll draw this. Okay, we want to find or solve for A, and we want to solve for B. This expression and 57 degrees, this angle, they're vertical angles. So this expression equals 57 degrees. So we'll set it as such. 2A minus 1 equals 57. Since they're equal, we can solve for A using this. We have 2A, and we'll add 1 to each side because we want this minus 1 to go. So add 1 to each side. 2A equals 58. Now, because these are multiplied, I can divide both sides by 2 to get A by itself. A equals 29. 58 divided by 2. So we have A. A equals 29. Since we know that A equals 29, and this is a value of 57, we can solve for B by properties of supplementary angles. If this angle is 57, this angle has to be a number plus 57, in which it will total together 180. So I'll write up here 180 minus 57 I have 123. So if this angle is 123, then I can do the same thing that I did for A. I can take this expression, 7b minus 17. Since it equals 123, I can set it to 123 and find out what B is. I have minus 17, so I'm going to add 17 to both sides so I can remove 17 from this side, but still have it and add it here. So we have an equal